the last lesson, we talked about redox reaction in terms of half cells, and how we can use the reduction potentials of the half cells to solve for the E cell potentials. In this case, we are going to talk about the two types of redox reaction. The first type is called spontaneous redox reaction. Think of the term spontaneous, that is, the reaction will carry by itself. In this case, to be more specific, a redox reaction that can occur without external power source. And when we have this type of reaction, we are building a voltaic cell or galvanic cells. So a galvanic cell is an example of a spontaneous redox reaction. Now, what is the opposite of spontaneous? It's going to be non-spontaneous. What does that mean? Non-spontaneous means it's not spontaneous, so therefore it is not thermodynamically favored. Whereas spontaneously, it is thermodynamically favored. That means it just happened by itself without external source. Where non-spontaneous, because it's not happening spontaneously by itself, it needs some outside source, and those outside source could be electrical power source, such as a battery to drive the reaction. Without this battery, there would be no reaction when there is a non-spontaneous redox reaction. And when we have that type of redox reaction, we build an electrolytic cell. Think of the word electro. Think about electrical or electricity that coming through a battery. That's why we call electrolytic cells. And we would have a non-spontaneous. So this would be non, and this would be spontaneous. Okay. Now let's talk about how to determine if a redox reaction is spontaneous or non-spontaneous based on the half cells, especially the reduction potential of the half cells. So let's compare the two different types of cells based on their type of redox reaction. Here we have the anode half cells that is made of cadmium electrode, but on the cathode side we have copper. But then we take the system and we flip it. That is, we are going to make the cadmium cathode and we're going to make the copper anode. In this case, we have cathode as cadmium and anode as copper. Now, how was that change the math in terms of calculating for the cell potential? And how can we relate cell potential to if the reaction is spontaneous or not spontaneous? And that is right here. When your cell potential of a system is positive, you would have a spontaneous reaction. Where in a non-spontaneous reaction, guess what is the opposite of positive? It's gonna be negative. So when you have a negative cell potential, you have a non-spontaneous reaction. And that is how you use the half cell's reduction potential to determine if the redox reaction is spontaneous or non-spontaneous. So let's do an example. So let's do an example problem. Here's the equation of solving for the cell potential, just oxidation plus the reduction. Just remember that if you are given in terms of reduction, you have to flip the signs of the reduction to get the oxidation, E potentials. So let's look at this problem. We have the cathode given in terms of reduction, which is cathode is for reduction, so we don't worry about that part. But for anode, which is oxidation, where oxidation occurs, and you are given in terms of reduction, guess what happened? You have to flip this sign, and now this has become negative 0.80. So when you solve this problem, you would have the oxidation, which is negative 0.80, okay, right there, and plus the reduction part from cathode, which is negative 0.40. That gives you a total of negative 1.20. Because this is a negative E cell potential, this tells you it is a non-spontaneous reaction, and the only way this reaction can occur is that it needs an external source, such as a battery. Now, if you notice the electron here, we have 2 and we have 1. When you're trying to balance out electron, we multiply this by 2, but here's one important fact that you need to remember. When you multiply this by 2, this does not affect the cell potential. That's the reason why I did not multiply the 0.8 by 2. So this is a very important statement that you need to remember. The E cell potential does not change by the factor when you balance out the electron. Let's try another problem. Here I take this and I reverse the condition around, where I take the cadmium and make it into an anode system. In this case, this will be oxidation, so therefore this is going to be positive 0.40 because it's oxidation now. Where cathode, this is your reduction, so this is staying the same. So we have plus 0.4 from oxidation, and then plus the reduction, which is 0.80. That gives us 1.20 volt, and that is your E cell potentials. If this is positive, therefore this has to be a spontaneous reaction. And that's how you determine if a redox reaction is spontaneous or thermodynamically favored, or non-spontaneous, thermodynamically not favored, based on the E cell potentials. Here I have the cathodes made of lead, and of course this is reduction, and then I have the anode made of chromium. This would be oxidation, so therefore the cell potential would be reversed, which is plus 0.74. So we take them and we add them together, 0.74 for oxidation, plus the reduction is minus 0.13, give us 0.61, and this is positive, therefore it is spontaneous reaction. Now what happened when I reverse the condition? I make lead into an anode, which is oxidation, so therefore this is going to be plus 0.13, where this is your reduction, so this is going to stay the same. So we have oxidation plus reduction, which is 0.3 plus negative 0.74, that gives us a negative 0.61 volt. If this is negative, therefore this has to be a non-spontaneous redox reaction.